Hey everybody, meteorologist Hutch Johnson, day 2, Tuesday. Hope you can join us. Make sure that we'll give people a second to get logged on. I see people popping in. Make sure you hit the like button. I can see who's joining class today. It was a lot of fun yesterday going through the locations that so many of you were watching from yesterday. Germany and Texas and all over the place. Wonderful to have you all. First and foremost, clouds are a lot of fun, and this is why you should listen today, and this is what we're going to learn. Without understanding how clouds work, well, meteorology just wouldn't be the same, because the weather we're all concerned about in our day-to-day lives oftentimes comes from clouds, right? Rain, sleet, snow, hail, thunderstorms, tornadoes, all of those things are all something that comes from clouds. Clouds are super important in our understanding of the atmosphere. And here is, let's see. There we are. Hi, everybody. Okay, so I'm meteorologist Hutch Johnson here at Valley News Live in Fargo, North Dakota. If you're joining us, Landon, hi from Moorhead. Good to see you here. Jackie, thanks for coming in. Fargo Daycare watching. Hi, kids. Hi, kids. We're thinking about you guys because normally you're in school at this time, and Hutch is a teacher of meteorology and weather. Every night I join you on the news, but I don't do a lot of teaching. There I'm working. I'm forecasting and telling you what you can expect. But for 20 years I've taught college-level meteorology classes, and this class and these subjects are boiled down to you, whether you're age 5 or 95. And I try to make it applicable to why it's important, and we talk a little bit about everything. Rachel, hi from Buchanan. Good to see you. Dubuque, Iowa. Wonderful having Iowans here. Oh, finally, we're warming up here in the northern plains. Things are still a little icy in the northern plains. Iowa, you've probably had a chance to melt a little bit of snow. And even some thunderstorms here not long ago. Jackson, thanks for watching. Katie, Mitchell, also excited to have Mitchell joining me now. Hi, Mitchell. All right, let's get into some of the facts about clouds and weather. First of all, when I was young, one of the things that got me into weather was looking up at the clouds and scratching my head and going, how does that happen? How's that cloud form? And I would lay there. Have you ever done this where you just watch shapes form in clouds, and a cloud that looks like a dog or a cat or an elephant or a giraffe, and you wonder about how that cloud formed or what could be happening there. Hi from Arizona, Mary Qualley. Good to have you on board. Zayden from Spiritwood and Carson. Good to have both of you. Hillsboro, Langdon, Fergus Falls, Valerie, and Kat. Good to have all of you watching. Now, clouds are really cool. I've got a few things to go over. Let's get right to it. First and foremost, if you do venture to put together a question for this, I'll try to be watching and monitoring for questions right here. But I want you to know that you can type those questions in, and if I don't get to your question live, I will try to do my very best to get to every one of those questions in the follow-up afterwards. We will leave this video online here, or you can go to Hutch VNL. Search Hutch VNL on Facebook, and I have it there as well. Love your likes. Love your follows. Howdy from Horace, Austin. Howdy. And Annabelle. Hi, everybody. Hi, Buckeye, Arizona. Little sweaty in Buckeye, Arizona. Good. Glad to have you here. Jill and Alexandria. Let's get right into it. Satellite and radar. These are tools for clouds, for meteorologists to see tools. And this is something you're familiar with seeing on your news at night. These white things here are clouds. And those white things that you see there are floating around and drifting through the atmosphere. And if we're going to have any luck forecasting our weather, we had better be able to forecast where there's going to be clouds and where there's not going to be clouds. So those are all important features. Now, if we zoom into your area, if you're in Arizona today, it looks bone dry. A lot of quiet weather in Arizona. For you in Texas joining us, a little cloud cover moving into Houston. And we've got Park River, North Dakota. So let's get right up to it. Here's Park River, North Dakota, and it's cloudy and some green stuff showing up on the radar. So these tools help us follow clouds. And as I mentioned, clouds are really important to helping us understand what kind of weather might happen this day. And you know what? Believe it or not, the type of cloud that forms over your sky can can help you decide a little bit more about how volatile or heavy that precipitation or weather you're going to get is going to be. So let's get into some pointers here. Get your number 2 pencils out. That's a picture of a cloud right there. These are Fairweather clouds over the Fargo-Moorhead area, and here is a look at some ingredients we need for making clouds. Let's make this fun, shall we? We got to have water vapor in the air. Water vapor is water that is a gas that you can't see. You cannot smell it. You cannot taste it with your tongue. It's not there, but it is there. To make a cloud, we got to take that air with water vapor in it, and then we got to cool it. And if we cool the air enough, well, then the air can't hold the water anymore, and that water condenses out. But it needs a place to condense. Down here, number 3, we need a condensation nuclei. But let's not get too boiled up in those specifics. Let's talk a little bit more about how we measure water in the air. If you watch Hutch on the news at night, once in a while you'll see us talk about a measurement of humidity. Humidity is how we measure the air. So I can go to my fancy pants graphics machine here and pull up humidity in the air and look at that. That's one way we can look at how much moisture is in the air. So I'm going to try to pull up our current conditions in Fargo right now, and the humidity's on there so that you know when you watch Hutch on the news or your local news in Arizona or Germany or wherever, you can get that information right there. Let's go ahead. Here's Fargo's conditions. This is what it looks outside today in Fargo, North Dakota. If you're joining us from across the country, we got some low clouds, haze, and fog. It is 41 degrees, and we're loving it. We haven't seen many 40s here in Fargo. You can see we still have a little snow, but right here it says dew point 38. Humidity, 89%. Okay, so we've got to track moisture as meteorologists if we're going to be able to find out where the atmosphere is going to make clouds. If we know where the atmosphere is going to make clouds, then we have a chance at predicting where it's going to be sunny, where it's going to be cloudy. And sometimes those clouds, not all the time, but sometimes those clouds make rain, like down here. Heading into St. Louis. St. Louis, getting some heavy rain there where you see the oranges, yellows, and reds. Okay, where we have blue on our color table here, if you're not familiar with our color table in the north, blue is snow, and pink is a transition between. So in the mountains of Montana, just west of Billings, Montana, past Laurel, Montana, and you'll see we got rain in the green, we got pink, which is a transition temperature. Who knows what the temperature that water freezes at? If you know, go ahead and answer in the comments below. Does water freeze at 100 degrees? Does water freeze at 50 degrees? Why is it so foggy? Jackson, that's a great question. That is a cloud forming on the ground, and we're going over exactly that today. Today, we're going to go over that, Jackson. So keep paying attention here. Humidity, moisture. Let's move on to the next thing. I mentioned if we have water vapor in the air and we track that water vapor. Good, Sarah, 32 degrees. Sarah Myers with the correct answer on when water freezes. Thanks for answering. Moving on. Cooling the air is important because if we have water vapor in the air, then, by God, well, Veronica said 0 degrees. Veronica, 0 degrees Celsius is the temperature that in the Celsius scale water freezes at. Good. A lot of 32-degree answers. Brady, Daniel, Susan. Good job, you guys. All right, here we go. Now, cooling the air. This is important. Rising air always cools. If we lift the air up into the sky, it cools because its pressure changes. Rising air expands, and expanding air has more room, and it cools. Sinking air compresses. Where the pressure is lower down here by the ground, sinking air compresses and warms, and clouds evaporate. So you can look at your satellite for any given day. And we know that if we're making clouds way over here, those clouds are being made because we have water in the air and we have rising air. We have no clouds out here south of Denver, El Paso, Frisco, Texas, where the Bison go and play annually, almost, right? All right, way to go, Bison. All right, down in the desert Southwest, sunny skies, no clouds, because air is sinking. Sinking air compresses and warms. There is water vapor in your air in Colorado. There's water vapor in your air in East Texas, right? It's a humid place out there. But not a lot of clouds happen unless we have rising air. So here we go. That's rising air, really important. So meteorologists need to, number one, we need to track where there's water in the air. Where's the humidity? Number two, How can we cool the air? That's with rising air. So we find places that have rising air, and we can forecast clouds. So let's talk a little bit about how this happens. I've got a computer that I'm just going to do a little drawing on here. So give me a second to get my computer set up here. Again, love to see you here today. If you have questions, you can leave them in the comments. Hi from Skylar, 7 years old in Langby. Good to have you on board. Just love doing this, you guys. I love teaching weather. I love talking about weather. Comment with your questions below. And if you're watching this and you have a cousin who lives in Michigan, all right, if you have a cousin who lives in Texas and you think they might enjoy this, go ahead and link them down below in the comments, and they'll be able to watch this video as well. Okay, so again, we're talking about the ingredients for making clouds. We need to measure the humidity in the air. Where is there moisture to make clouds? And if we have moisture, where is there rising air? Because rising air will help make clouds. And once we have rising air, clouds and the cloud type that forms, like the ones you see in this pretty picture here, okay? Horns up, Bison, Bridget, you got it. Okay, these pretty clouds here are Fairweather cumulus clouds. They're not going to rain, sleet, snow, hail, thunderstorm, or tornado. They're just Fairweather clouds. The type of cloud that you get depends on how fast that rising air is, how violent that air rising motion is. Excuse me, Hutch needs a sip of coffee. Let's talk. Isn't this cool? All right, so here is a wiggly movie. I just bumped my camera. Can you tell I'm a rookie? Hi, Emily, 9 years old. Love having you here. Thanks for joining us. Okay, let's go ahead and move the earth a little bit here. I am going to tilt it way down. Now, we're going to make us a cloud here. And with this cloud, we're going to try to... where is my toolbar? There we go. Okay. Let's make clouds. Let's say on a day we have fair weather clouds, wispy clouds like these ones, okay? We have rising air, we have moisture at that elevation in the atmosphere. Now, these kind of thin, wispy clouds can form at any elevation, high or low, okay? And they form best when we have rising air. And that rising air, okay, let's see if I can draw on here. It's getting hard. Let's see. Well, let's use this arrow. Okay, rising air going up into the cloud is rising gradually to make this thin, wispy little cloud. So we have just a little bit of air rising, just a little bit, fairly slowly here on Hutch's screen. So a little bit of rising air up into the cloud. And it's rising gradually. Now, we have other kinds of clouds form as well. Let me go ahead and put up this type of a cloud. These we see more this time of the year. These are cumulus puffy clouds. Cumulus clouds can also form at different layers. They can form way up high in the ice crystals. Those are usually bright white. They can form closer to the ground. Cumulus puffy clouds form by a rising puff of air. It's like an air bubble, a hot air balloon rising up slowly. And slow rising air will make little towers like this, little cumulus bubbles. Once in a while, if we get more rapid rising of the air, one of these cumulus clouds might be growing a little more tall, called towering cumulus. Those are forming under air that's rising more rapid. Okay, so if we get a rapid rising bubble of air because it's superheated, let's say you live in Bismarck, okay? And if you live in Bismarck and the parking lot at Kirkwood Mall in the summer gets hot, if you live in Fargo and you're at West Acres Mall, that parking lot gets hot in the summer. The sun shines down and that asphalt gets to be 120 degrees. That hot air rises faster than warm air on a summer day over a prairie or pasture field. So over the prairie or pasture field, we might get this cloud right over here, this thin guy. Not very tall, not very volatile. But if we get into over the Kirkwood Mall parking lot or the heat of the city of Fargo, we get the towering cumulus cloud forming. Okay, let me erase my board here. Hi, Macy. Megan, good to have you on board. Heather, good to have Moxon 7 from Gwinner here. All right, let's talk about when we get real violently rising air. That means the air is really going to rise fast. We can have these towering clouds called Cumulonimbus Clouds. These clouds are way different than your normal cloud like we have over Fargo today. These clouds can grow to be 50,000 feet thick. So this little thin, wispy cloud that we see here on the left side of Hutch's screen over here, those things might be 1,000 feet thick, a few hundred feet thick. And on some occasions, those stratiform clouds can be 5,000 feet thick. Okay? But when we get a towering cumulus cloud like this one forming in the atmosphere, that towering cloud can be 1,000, 5,000, 10,000 feet high. These bad guys over here, these clouds can be 30, 40, 60,000 feet high. That's right. They can be huge, enormous, ginormous. It's a big word. Aaron from Moorhead, Minnesota, good to have you on board, age 11. Glad you're joining us. If you like what you're hearing, comment like. Wows are great. Hey, sometimes thunderstorms can be a little scary, right? We got lightning that can happen from thunderstorms. That's pretty dangerous because it happens so fast. It happens faster than Hutch can snap his fingers. I do not like lightning, so I take precautions during lightning. That's our topic for day 5. We'll save that. Now, thunderstorms can produce heavy rain. Thunderstorms can produce hailstones as big as baseballs or even bigger in some of the stronger storms. But Hutch likes to equate how fast that air is rising. That is the point I'm trying to make here. The speed with which the air is rising dictates the type of cloud that you see forming over your town. If you get one of these little wispy guys forming, then it's just a light little puff of air that's gradually rising and ain't no big deal. It could make rain, but it likely won't make real heavy rain. If you get thicker clouds, 5,000, 10,000 feet thick, there's a little more rising motion in there. There's more bumpiness going on, and cloud molecules bump into each other and grow faster. Those can make raindrops faster, and you might get a little heavier rain. But when you get one of these guys forming right here, these cumulonimbus clouds, these guys can make it rain very, very heavy. So we're talking 3 to 5 inches per hour or more down in tropical systems. Now, there's all kinds of different fun clouds. Funnel clouds can form from different types of thunderstorms, and we can have those. Now, a funnel cloud is a cloud. It's a cloud that's a funnel that's not in contact with the ground. So it's usually attached to a parent thunderstorm. So let me draw a parent thunderstorm here. Here's our parent thunderstorm growing from the sky. And now let's have a funnel cloud dipping out of the base of it, if I can. Okay, let's see. Give me 1 minute while I make my computer cooperate. There we go. Let's see. Let me try to draw a funnel cloud. Okay, when there's a spinning cloud moving out of the base of that big thunderstorm, that's called a funnel cloud if it's rotating. Sometimes we have funnel-shaped clouds that look scary. Hutch calls them SLCs, scary-looking clouds. They're not all funnels, and they're not all spinning violently. When the funnel cloud makes contact with the ground, you have a tornado. So, clouds, really important. Clouds are important to meteorologists to track, to follow, and I thought I'd end with a couple of fun things. Cool clouds can form. This is an example of, let me slide over here. I just did a search on YouTube, and you can do this yourself because I don't want to show copyrighted material and stuff, but we can get all kinds of beautiful clouds forming it, and we can time-lapse them. Here, this time-lapse shows you that air is rising over a mountain peak. Remember, rising air cools, we form a cloud. Sinking air, look what happens to the cloud where it's sinking. It goes away. Rising air cools the air. We make a cloud if there's enough water in it. Sinking air compresses, the cloud disappears. Really cool stuff. Hutch likes this. This is kind of fun, right? Here is time-lapse of an ordinary day where we have rising pockets of air forming cumulus clouds, puffy cumulus clouds. These don't look threatening. They don't make rain right away. They're darker at the base because they're a little thicker than those wispy clouds we just saw. But sometimes these can grow into more significant towering storms. So these clouds here, cumulonimbus clouds, look how tall they are. Look how thick they are. Now you know why when one of these storms moves over your house, it gets so dark outside. You have a cloud that's 50,000 feet thick, like this guy on Hutch's screen over here on the right, and it's blocking sun from getting down to the ground. That's today's lesson. Now, I want to leave a couple minutes. I've talked for 20 minutes. Okay, I'm leaving some time for you to ask questions in the comment section below. Remember to tag people that you think might be interested in Hutch's lessons here. We have 3 days left this week, and we'll see where we go from there. But I got to tell you, I've really enjoyed doing this, preparing for it, and making clouds is kind of fun. So while you're thinking of your questions and typing them in, I got something for you. Here is a little video, and let me see if I can find it. Here we go. Oh, there's Pedro. Let's see. Here. Okay. Hutch's cup of coffee's making a cloud. Look, there it is. Boom. A little bit of evaporation from my coffee, and it condenses in the cooler air just above it. I'm making a cloud. If you really want to make a cloud in your kitchen, get your mom or dad or you, get over to the stove, boil you some water, and make some scabetti, as my son calls it. Scabetti is what he calls it. I love it. Okay. Scabetti's great. See all that? We call that steam, but really you're making a cloud in your kitchen. You're adding moisture to the air and you're cooling it right over the pot because that hot air cools very rapidly, makes that steam that you see. Now, another place that you can make steam is, of course, in the bathroom. So when you have the hot water from the shower running, the shower fills your bathroom with humidity and moisture in the air. That moisture in the air condenses, and it condenses on things like your mirror, your toilet seat, the faucet handle, because those places are cool. They're cold. We have to cool moist air for it to form the condensation. So a couple of fun things for you that I just did today. All right, a couple questions. Let's see if I can scroll back through here and find them. Let me gather my video screen. You don't want to stare at this. All right, here I am. I'm going to look over here and get a couple questions. Hello, Ben and Eric from Grand Forks. Good to have you on board. How can I make clouds? And how can clouds make a tornado? Jen, that's a question from AJ. How can clouds make a tornado? Scientists do a lot of research. Meteorologists do a lot of research. And sometimes the atmosphere has spin in it. Okay? And days that we can have spin in it is a day like this. Have you ever been outside when you look up at the clouds and the low clouds are coming at you like this? And then you look a little higher and those clouds are drifting in a different direction. So we have two layers of the atmosphere. The high clouds moving this way, the low clouds moving that way. That's called wind shear. And meteorologists watch for those ingredients. If we have rising air that's rapidly rising, aha, we can have thunderstorms. But if we have rapidly rising air in an environment that has shear in it, look out, we can have spin. So our clouds have spin in them. The rising air of a thunderstorm is bent vertically, and we can get these rotating columns of air called rotating updrafts. Rotating updrafts can make tornadoes. So I hope that, AJ, helps answer your question. Some of these are pretty technical, but I'm doing my best to explain them in a way that makes sense. When there's rain, why are clouds gray? Angie asks, when there's rain, why are clouds gray? The thicker the cloud is, the darker the gray color the base of the cloud is. So on a day like today in Fargo, okay, our tower cam time lapse is right behind me. You can kind of see it in the background over there. We have a gray, soupy kind of day as we forecast yesterday on Valley News Live if you joined us. Well, the thicker the cloud is, the darker gray you get. So when we have a raining clouds are usually a little thicker because they're making heavy raindrops. We can have a cloud that forms on the ground. That's called fog. When a cloud forms on the ground, we've all been outside and walked through those kind of clouds, right? We don't always get dripping, soaking wet from walking in fog. We just don't, because cloud droplets are tiny, tiny, tiny. We'd have to walk into a lot of those cloud droplets before we got wet. So for a cloud up in the sky to make raindrop-sized water drops that can fall down through that rising air, fall down through the updraft, takes a bit of time. And those clouds are usually thicker. The thicker they are, the darker the gray is. I hope that answered your question. Mason is wondering how you keep changing the weather. I don't change it, Mason. I just forecast it. All right, Addison 9. Why, when you are in an airplane and go through clouds, does it get bumpy? Oh! Addison, 9 years old. Why does it get bumpy when you're riding in a plane? That's such an awesome question. We could be here all day talking about these questions, but let's get to this one. Addison, if you're flying on a plane and the plane is going through smooth air, that there's not a lot of rising motion, because we don't go outside every day and experience rapidly rising air where our hair just blows straight up. That don't happen. We don't walk outside every day and a downdraft hits us and our hair goes down and we feel air moving down. We feel wind moving horizontally, right? But in the upper atmosphere where planes fly, there is some rising pockets of air and sinking pockets of air. We saw it on that time-lapse video of air moving over a mountain. So air in the atmosphere can have waves like this. And if you're on a plane and you're flying through air that has an updraft, all of a sudden the plane goes up. And then it hits a downdraft and then it goes down. And it feels bumpy to you because that plane is moving at about 500 to 600 miles per hour. So you have what we call turbulence. And that turbulence can happen in clear air, even with no clouds. Awesome question, you guys. Okay, you guys are asking some really cool questions. Bethany Swanson, I am homeschooled, and all of us are homeschooled today, right? Because our schools, even colleges, are closed. AJ asks, how do tornadoes form? I just went over that. Thanks so much for your question. When should you be worried about funnel clouds? Who asked that one? When should you be worried about funnel clouds was asked by Jody. Jody, anytime you see a funnel cloud, you need to get out of the way of that storm, because a funnel cloud can quite quickly touch down to the ground. So you need to be concerned about funnel clouds anytime you see them. The farther away they are from you, the more time that you have. And kids, if you're home and you get scared of weather like thunderstorms and lightning, funnel clouds and tornadoes, and they really make you nervous, I got an idea for you. Read as much as you can about the weather. Learn as much as you can about the weather, and you will learn how storms usually move, how to stay safe, how to know when it's coming towards you or when it's moving away from you. And these are all things that our storm chaser, Eric Whitehill. Hi, Eric. Hope you're watching. And if not, we'll talk to you soon. But Eric Whitehill knows these things and practices safe observation of the weather. You guys are asking awesome questions. So if you see a funnel cloud, it's time to get inside, particularly if it's fairly close to you. Hutch, my two sons are watching. Could you explain some of the characteristics of a wall cloud and how they can be you can detect it from ground level? Casey, that's awesome. It's a pretty technical thing, but I'm going to try to do my best, okay? I was a lot gooder at math and science than I was at grammar and English, and that's why I'm a weather guy. Okay, let's go to the wall cloud thing. Real quickly, if you get a thunderstorm forming, thunderstorms form from rapidly rising pockets of air. Rapidly rising pockets of air are cooling, okay? So sometimes, let me see if I can do some editing to this. Let's go here, pardon me, while I go to properties of this. I'm building a graphic in real time, so you get to see some of the fun Hutch has in his job while I'm building graphics. Okay, I'm going to turn this cloud upside down and make it look like it is a, let's see, 0, 90, 180. There we go. That didn't do it. There we go. Okay, so in the rising part of the cloud, where the air is rising fast, once in a while, we can have one of these form. Okay, and this is a, now why won't it let me place you? Okay, my computer is acting a little goofy. Let me go ahead and click here. Let me click here. And let me click here. And let me click here and see if it'll let me put it on now. Oh, I see what's going on. Okay, so once in a while in the updraft, underneath on the base of the cloud, you'll see a lowering of the cloud base. Thunderstorm bases are typically very flat. So when you take a look at this cloud, this thunderstorm cloud, it has a flat top and a flat base. The flat base happens because that's the temperature, that air at that level is at the temperature that the cloud forms. It's important. It's a cloud base. Sometimes we see a lowering of the cloud base that bubbles down toward the ground. That is called a wall cloud, as long as it is attached to this parent thunderstorm. If it's a cloud that looks kind of goofy and it's over here detached from the parent thunderstorm, not a wall cloud. But in the rising updraft, Wall clouds form often on thunderstorms. They don't always mean a funnel cloud. They don't always mean there's going to be a tornado. So you have to watch that wall cloud closely to see if it's spinning or rotating. You guys are asking great questions. And again, some of this is getting technical, and we can definitely talk about that. But for today, I think I'm going to wrap up. How is lightning formed? Alden in Grand Forks, North Dakota. Alden, we're talking about lightning on Friday. We're going to charge it up. So let me end by saying this. You guys are awesome. I love your comments. Let me know what your comments are. If you have ideas for what Hutch should talk about in a class down the road, if we continue this, let me know what you want to talk about, what you want to learn. I will read all of these. It's going to take me some time. We have hundreds of comments, and I appreciate that. So if you've enjoyed class today, thank you so much for logging on, for watching. Watch it later. Send a link to your friends or your cousins across the country. Maybe they'll enjoy it too. Class for the rest of the week. And I got to thank my sponsors at Luther Family Ford. They make this possible. They sponsor our Weather Kid program. And because we don't have a Weather Kid program right now, because of what we're all going through, this is a great way for us to get together and pass along some weather information. Tomorrow it's wind, air that is in a hurry. That's what wind is. We're going to talk all about it. And then we'll heat it up with some talk about heat, and then we'll talk about lightning on Friday. Comment with what you'd like to see. Comment with what you'd like to see me improve on. I am learning, and I'm not a daily streamer. I'm a daily broadcaster. We have big tools to make our broadcasts a professional thing, and that's what we do every day. Not streamed every day, so I'm trying my best to make all of this make sense. Hope you had fun. Hope you enjoyed it as much as I did. Here's my cup of coffee. Hope to see you on Valley News Live tonight. Again, like below, and go ahead and go to Hutch at Valley News Live. Love to have you like my page. You can also find this video posted there. We will see you for class tomorrow. I better get to work. It's 2:32. Thank you. Thanks, Courtney. Thanks, Casey. Thanks, everybody.